Hi, this is Professor Cummings, and this is again Mod 1, Module 1, and now we're into the Lecture 3, or the application lecture. So this will be the part where we go over a case study to kind of drive home some of the points that were taught in the previous lectures of Module 1. Now, I don't know everybody's background in this class, but if you've ever worked in a steel mill or a foundry or any sort of steel or aluminum processing plant, it can be a pretty dirty, pretty dangerous environment. And in order to understand this particular case study, you need to understand a little bit more of the background on manufacturing steel and aluminum or just metal processing, especially in the earlier refinement stages and process stages. Just not because this case study goes specifically over these details, but just to give you some picture as to what type of environment these people had to work in. So again, that's just a small picture of steel being processed, being cut into billets, and that's going to go on for further processing. So let's get into a little bit more of the background here. So when you make steel, one of the keys, or three of the key things you need to make steel is you need iron ore, then you need limestone, and you need coal. Now, the purpose of these three ingredients is iron ore is the basis of the entire product you're going to make. It's iron ore. It's iron that has been mined from the ground. It still has a lot of the impurities in it, and it's not refined. It's basically useless at this point. It's just iron with all the impurities still around. It has to be crushed into usable size pellets. The limestone is a fluxing agent, and what the fluxing does is it actually removes the impurities. It's actually, you see this, different types of fluxing agents depending on the base material, the ore material, is actually used. So bauxite is useful in aluminum. Different types of materials all have their one they need, and limestone is actually one that works with iron. And then of course you need coal. Coal is refined and it makes a fuel source known as coke, which can burn much higher than limestone. So what you end up with is, here's a cupola furnace, also known as a bloomery. The ore, limestone, and coke all go into the top of the furnace. The coke is burning and creating a lot of heat. The limestone is actually drawing out a lot of the waste, which is known as slag. So it's draining the slag off, and what you have here is the molten iron. So think of it as the iron is just getting all of the junk pulled out of the process. Now, this process, like I said, is a very dirty, very hot, very dangerous process. At this point so far, so it's the air is not clean, and it's a lot of potential safety issues in this process. So a very brutal environment to work in if you've ever worked in a foundry or metal processing plant. So now, once you have refined the iron, you've taken a lot of the impurities out of it, you still have a certain processing degree to go to with it as terms of before you can make it into something useful. So the main thing you're concerned with iron, other than all the other impurities that come from just being at the ground, is the carbon content. And if your carbon content is below 2%, it has to be below 2% before it can actually be called steel. So your low, medium, high carbon steel. And even once it is steel, or once that carbon content is correct, it still has a lot of alloying agents that have to be put into it, like chromium, which makes it shinier and rust preventative, molybdenum, as well as things like sulfur, all that goes into to make it so it's actually useful. So that you can actually make this so it's either ductile enough to work, or corrosion resistant, and other properties that you need. So there's still more refining that has to take place. Above 2%, you've got cast iron, pig iron, and all the way up to cementite, which is an extremely brittle material. Now, another process that goes through the manufacturing of steel and aluminum is going through the rolling process. Most of you could go into a Home Depot or some other end user type store and actually buy steel. That steel has been rolled. They didn't just give you a billet of steel. It's actually gone through this final rolling process. So, and there's two types. There's a hot rolling and a cold rolling of steel. And the big difference is hot rolling takes place at elevated temperatures, and cold rolling takes place at cold temperatures, room temperature. Cold rolling is much more precise. It's much more expensive, and it tends to also have some stress issues with it. But again, it's just two different options. If you ever go and buy steel, you're either going to have the option of buying hot rolled steel or cold rolled steel. And in this process, it's actually rolled to a very specified dimension. That's why you can go into a supplier and ask for steel with a very specific thickness to it. Very specific thickness, because it has been rolled to dimension or into a very specific shape, square, round, whatever the bar stock is. So that's some background. And hopefully what you got from that is that, yes, making steel is a very complicated and potentially very dangerous, very hard, not so easy process to do. So what does that have to do with this? Well, there was a steel manufacturer that wanted to produce or use Lean Six Sigma in order to help their process. And there's a case study that a consultant put online that I thought would be good for the class. So just keep all this past information in mind when it comes to producing steel and aluminum as we go through this case study. So the scenario. The industry is aluminum and steel manufacturing. So all the things that I just showed you in the previous slides are applying now. And the issues that that company is facing is timeliness, being able to get product out on time, meeting their deadlines, a lot of wasted materials, and excessive use of manpower. So their manpower is not being used appropriately. So they called in a consultant, and this is what the consultant had to say. Our client had a challenge with excess transportation and handling from the production machinery to the washer flow, causing serious waste problems with oily crates, oily floors, and wasted plastic linings. So as you can see, you're making steel. You want to keep this stuff from rusting, so it tends to give it an oily coating. After, of course, it's not hot enough to catch fire. As this was so much waste, this job required the hard work of 5 people. So as you can see, there were 5 people. Apparently it's an excessive amount for their current operations. There were 5 people that are actually working on this process because of all the oily floors, the oily crates, and all the plastic linings that were getting basically used in trying to keep this stuff transported and keeping the quality good. So the processes are not necessarily laid out to facilitate flow. This is important. They're not necessarily laid out to facilitate flow. The layout typically evolves from the standpoint of where will it fit rather than how does it need to be laid out to facilitate flow. Again, keep that in mind. These are very important points. Where does it fit rather than how does it need to be laid out to facilitate flow. This is very, very common in a manufacturing setting where machines are oftentimes put into position based on when they showed up and where there was room versus what would be the optimized layout. And that's mostly because, you never know when you're going to get a machine, you never know when you're going to expand, and riggers, the people that move machines, are oftentimes very, very expensive, so a lot of companies cut that corner. Okay. This approach typically results in multiple types of waste, which again is very, very true and very, very common. A lot of waste is produced just from that very sloppy habit. And some of those types of waste are excess WIP, which is just work in process, handling, moving parts places from place to place, transportation, which is again moving stuff throughout the plant. So I guess handling, you could think of that as just handling from machine to machine. This is just moving it from operation to operation. Because keep in mind, these machines aren't necessarily where they need to be. They're not in a logical order. They're just in the same place, same building. And overproduction. Now, here's something I want to point out. WIP, like I said in the lecture before, of the 7 types of waste. Overproduction as well as downtime, those 2 types of waste tend to have a byproduct, and part of their byproduct tends to be WIP. So if you're overproducing, you're likely to produce WIP, and if you are having excessive amounts of downtime, you're likely to get WIP. So again, keep that in mind. This is, if you've got a lot of WIP, that's usually the byproduct that there's something going wrong in your system. So this is the case so far. So the goals of this case is they want to implement one safety and ergonomic improvement per team member. Okay, they want to improve productivity by 20%. They want to reduce the lead time and the work in process. And they want to implement standard work for all operations. So they want to implement a set of measured steps for each operation that will make them more efficient. Now, if you remember from lecture number 1 on lean, who was standard work? Who do we associate standard work with? So standard work. So the whole concept of standard work again. So let's see. So they had a Kaizen event focusing on the work effort of 8 to 10 people. So they got a team of 8 to 10 people to come together and implement the solution to the problem. This is accomplished with 3 to 4 weeks of preparation. So they went through 3 to 4 weeks of actual preparation prior to the week-long Kaizen event. Okay, so they prepared for 3 to 4 weeks and then they had a week-long event. Both the consultant and the team members worked hard to make sure that everyone is on board. So all the team members and the consultant wanted to make sure that people outside of this team of 8 to 10 people are actually on board with what they're doing, with the upcoming changes, and that there is a mutual understanding that these changes will carry positive growth in the company. So they wanted to set the stage for everybody else. So they got these 8 to 10 people, likely from different aspects of the company, that all knew different parts of the process. What's that familiar with? Again, go back to lecture 2, where we talk about, back to lecture 1, where we talk about value stream, and then making the value stream map. So they went back and looked at this and got a carrying the positive growth of the company. Now, just for the record, just take a pause here. They use a couple of words there that I want to make sure we get out. They use the word Kaizen and Kaizen event. Kaizen is just a Japanese term that it means change for the better, so some sort of improvement. And in terms of Lean Six Sigma, a Kaizen event is a one-time event that addresses a problem. So this was essentially a brainstorming session, a very high-level brainstorming session. They took these 8 to 10 people, got them together for this, this 1 week Kaizen event where they looked at the problem. They did a value stream map, most likely did a value stream map, looked at the entire process, and then using the expertise of those 8 to 10 people, came up with a way of improving this process to achieve their end goals. So back to the case study. The team came up with a layout where the operations were located side by side. So they just rearranged the layout of the plant. And instead of going with the wherever it fits mentality, they went to a location side by side mentality. So the operations were side by side. And basically, they made it more efficient, thus eliminating transportation. One of the 7 types of waste. Handling, another of the type of waste. And in this case, batching associated with WIP between machines. Again, what is WIP? It's the byproduct of overproduction or downtime, or some other form of waiting, which is another form of waste. So again, what they did by rearranging the value stream map, the process flow, they were able to eliminate several different types of waste. In addition, this helped remove cleaning of oily rags or oily crates, the oily floors, and the usage of plastic lining. So they had a much more efficient flow. They didn't need all this preventative for rusting. They didn't need to worry about the potential for rusting of steel or any type of corrosion. So therefore, no oil on the parts, no oil on the floor, no oil on crates, and no plastic lining. Also, they optimized processes based on takt time. So again, their flow was better, so they were able to meet their customer better with improved takt time, and improve their productivity by 60%, which was one of their goals. So the results of that event, that Kaizen event, was productivity. The number of operators went down from 5 to 2. Now again, they got 5S, which was just another lean tool of making the house safe. The work in process changed from 1,722 hours to 16. I believe that's hours. The lead time went down dramatically, 1.5 days to 20 minutes. And the costs, or hours per piece, went from 72 seconds per piece to 40 seconds per piece. So they met all their goals. They had a very dramatic improvement in all their productivity, as well as made a much safer environment. I mean, could you imagine being on an oily floor in a hot, environment capable of melting steel? So some of the questions I want you to walk away with, and some of the things I want you to contemplate, besides things like, references back to Fred Taylor and Henry Ford, when you think about what was one of the benefits of the assembly line, it put operations in close logical proximity to one another, which is the thing they did when they did their process flow. There's several other questions and several other lessons that I'd like you to take from what we've done previously. So some of the questions. What other issues could this company have faced without Lean Six Sigma? In other words, they identified oily rags, oily crates, plastic liners, not making deadlines. What were some other things that most likely were happening because of their inefficient layout? That wherever it'll fit mentality that goes with most manufacturing facilities. What were some things that you suspect? I mean, again, this is your speculation. This isn't me telling you there's a right or wrong answer. We don't know what this company was. So what were some of the more possibilities that went with this? What was the benefit of the team? Now, why did they have a team of 8 to 10 people? Could one person have addressed this problem? Was this something that they really needed 8 to 10 people for? And again, think back to previous lectures and understand, what all must have gone on, the details that weren't specifically stated in the case study. What details would have had to have happened in order for this to take place? And what was the value of the 8 to 10 people on the team? Okay. Why was the team concerned with everyone being on board? So everybody was on, they actually spent a lot of time making sure that everyone was on board and making sure that they knew what was going on. And what would happen if a few employees disagreed or just didn't care? How would that have affected the company as a whole? Okay, so these are just some questions on Lean Six Sigma. So this is the last lecture for Module 1. And you can go ahead and do your assessment, and then we can move on to Module 2. All right, this is Professor Cummings. Thanks for watching, and thanks for taking the class. I appreciate it, and we'll talk again soon.